been talking about vector data structures, and then specifically shapefiles, and then feature classes more broadly, I'd like to take a few minutes to talk about the difference between shapefiles and layer files here in this video. This topic is a little bit specific to Esri's ArcGIS software platform, but it really also has to do with what shapefiles are capable of storing and what they're not capable of storing. And so you also see similar concepts, similar ways of handling the situation that we're going to be talking about in a lot of different software platforms as well. I also want to address this topic because of some confusion that sometimes results from terminology that's used. Sometimes the term layer is used a bit differently in GIS data theory in general than it's used when talking about specific software implementations. So I want to make sure we clarify that. The first thing I would say that it's pretty common in the GIS literature and GIS theory to talk about data layers because we talk about layering data on top of one another inside of a particular GIS project. And this is something that you're at least probably intuitively aware of and familiar with throughout your use of GIS, getting familiar with it in an introductory course. It also strongly relates to the idea of the feature class in the broad sense, which we had talked about previously. You might want to include GIS data about streams, lakes, and roads in an area in a single project. That sounds like something you might be interested in doing. So in this case, you would have to have at least 3 different feature classes in this broad sense involved in the project. If you were using shapefiles, then you'd have 3 shapefiles. You would have one that holds the area geometry of the lake, one that holds the line geometry of the roads, and one that might hold the line geometry of the rivers or the streams. Then you would add this into your project and layer them on top of one another since you can view all of the relationships, or so that you can view all of the relationships between the lakes and the streams and the roads. And of course we know the coordinate systems and the sets of assumptions that were used when the geometry was created, so they'll all align in their correct geographic position. So when we stack all of these feature classes on top of one another in a project, we often use this term layering. What we're doing is we're layering this data. I've tried not to use the term data layer in this way in order to avoid confusion in these videos between layer in the broad GIS theory sense of the term and then layer in the more narrow ArcGIS software implementation. So I've been using the terms data file, or sometimes GIS data file, or vector data file, instead of layer in this broad sense. Therefore, using the example that we just went through, we'd have one data file, one vector data file for the roads, one vector data file for the streams, and one vector data file for the lakes. And I've been doing that in order to make that separation between the GIS theory and the software implementation that also uses this term layer. And I don't want there to be that confusion. Actually, this is something that you do see a lot. Having a term used in general GIS theory that is used differently in a particular software implementation. And so it's very important in general to be aware of that and to not get confused with the terminology, because different software packages will use all different kinds of terms in ways that we might necessarily use them in geography and GIS theory. So those things may not always be in perfect alignment, all of that terminology, and that's just something that we do have to get used to in GIS. Okay then, let's take a look at what layer means in the context of the ArcGIS software package and how it relates to shapefiles and what kinds of things they can and cannot store. So to refresh your memory on shapefiles, there are a few things that it does store. Most notably, we know that it stores feature geometry, and it also stores attribute information. So we looked at that file structure in a previous lesson when we said that it was the .shp file that stores the geometry, and then the .dbf file that stores the attribute information. Then, of course, there's the index file and hopefully some other files in there besides, but for the purposes of this video lesson, the geometry and the attribute information is what we're concerned with. However, beyond those things that we want to store when we're talking about shapefiles and what they store, there are other things that we might want to be able to store about our GIS data that isn't included in that shapefile structure. And there are two very important things we need to think about. One of these notable and important things has to do with your selection information. You've probably worked with selecting data already inside of a GIS data package. We've talked on that briefly already, and we'll talk about two major ways that we can use to systematically select GIS data in future video lessons. But being able to select some particular selection or subset of an existing data file is very important, but it's not something that a shapefile can store. There's no component of a shapefile that stores selection information. Another important thing that we may want to store is a particular way of representing a GIS data file. In other words, we may want to store its symbology. I know you have experience symbolizing GIS data files in different ways. Unfortunately, there's no way for shapefiles to store symbology either. There's no component file of the shapefile that allows you to store symbology. So in order to do this, in order to store these two different things, which are very important, you need a different file entirely. You need a file called a layer file within the software package, and that has the .lyr extension. So layer file, .lyr file. Critically, this layer file, the .lyr file, stores three things. And the first thing it stores is a link to a shapefile. Okay, they store a link to the shapefile because layer files do not store any geometry and they do not store any attribute information. That's what the shapefile is there for. They have to, in a manner of speaking, pull that information from the shapefile that it is being linked to. And so technically what they do is store a path to a particular shapefile. That computer, go to see users, my, documents, and then look in this folder and get this shapefile. That's what we're talking about when we're talking about a path. They store that path to a particular shapefile, and this means that very similarly to how we've already looked at what happens if you don't take your data with you when you save a project to work someplace else? That your project isn't going to work because the data the project just references the locations where all of this data is stored. It doesn't save all of that data as well. Well, it's the same thing with these layer files. You could have great layer files, but then if you delete the shapefile to which they are linked, or otherwise move the shapefile, then it's not going to be able to find that geometry or that attribute information, and so the layer file isn't going to work for you. So that link to the shapefile, which stores the attribute information and stores the geometry information, is very important. But second, the layer file can store that selection information that has been made on a shapefile's data. You may have executed a very complex query on a data set and have a resulting selection of it, and you may want to save it for later, send it to somebody else. Maybe you've selected all of the counties in the United States which are most suitable for you to open a business in and want somebody else to review it. Well, by creating a layer file for that shapefile, you're going to be able to store that selection information. Likewise, some people spend lots and lots of time carefully symbolizing data for a particular project. They want it to look nice. They want to be able to create great maps from it. And it sure would be a shame to have to replicate all of that work to symbolize all of that, the exact same thing, in a different project. You spend all this time in one project setting up your symbology. If you want the same data symbolized in the same way in another project, you don't want to have to spend all of that time. So by saving the symbology, you could import it into a new project. And that's the third thing the layer file can save for you. This layer file can save your particular symbology for a data set. This explains why when you bring a new shapefile into a project, it appears in a random color. And that's because the shapefile doesn't store any symbology information. Technically, a project can't add a shapefile to a project. You can't add a shapefile to a project because it needs some way to display that shapefile's geometry. So technically what happens when you ask ArcMap to add a shapefile to a project, it automatically generates a layer file for that shapefile and adds that layer file to the project. Since the symbology hasn't been specified, it was just created, it selects some random symbology, some random color to display your data. We all know that if you look in our catalog, the icon for a shapefile is that green rectangle. The icon for a layer file is the yellow diamond. This also explains why the Add Data button in ArcMap shows the little yellow layer symbol instead of the symbol for a shapefile or some other file type. It's because what's technically being added to the project needs to be a layer file. When you look at the properties of the layer that you added, you're seeing the path to where that particular shapefile that the layer file references is stored. So storing the selection and the symbology separately from the shapefile also helps us to be much more efficient with storing information because it makes selections and symbology reusable between projects. You may want to symbolize a single shapefile in multiple ways for multiple projects. It doesn't make sense to resave all of the geometry and the attribute information just because you want to display it differently. That would be an extremely inefficient thing to do because of all the redundant data that you would have. These shapefiles or GIS vector data files in general can get very, very large. You don't want to have to resave them just because you want to display them differently. You'd get all kinds of redundancy and have all kinds of problems. So this setup lets you save all the geometry and the attribute data that you have once in a shapefile or other vector data file format, but then create multiple layer files. And these layer files are much smaller in size to store the different symbolic representations of the data that you'd like to have for multiple projects. The same thing applies for multiple selections that you would like to save and consider, even though all of the different selections are based on the selecting the same or the data in a single shapefile. Save those selections through multiple layer files. Don't try to export a new shapefile every single time. You're becoming very, very inefficient and creating all kinds of redundancy. That's what the layer files are there for. Another reason that I wanted to introduce you to the difference between a layer file and a shapefile now is because it becomes extremely important when you're doing different kinds of selection and geoprocessing tasks when we're talking about solving problems or answering questions. If you're going to perform some kind of function, like most of the geoprocessing functions that we're going to be talking about in later lessons, and thereby systematically manipulate the geometry and attribute tables of some data file, then you're going to have to give that tool a shapefile or other vector data file to work with, and then the tool is going to, or the tool or operation you're performing, is going to return another shapefile with the new updated geometry and attribute information. Because in order to save the updated geometry, in order to save the manipulated geometry or attribute information, it's going to have to write out a new shapefile because that's what stores the information. On the other hand, if you want to perform some kind of systematic selection of the data, either by location or by attribute, then it's impossible to select a shapefile. You can't actually make a selection of a shapefile. You're going to have a layer file to send that selection tool or selection operation. Then it's just going to adjust the selection parameters of the layer file. It's not going to need to create a whole new layer file because it can just switch around what is and is not selected in the layer file. We're going to look at that in more detail as we progress into other lessons and also much more in more advanced GIS courses. But I want to introduce you to this difference now so that it can at least be in the back of your mind. You can begin thinking about it. Remember that shapefiles store geometry and attribute information, among other things, but attribute and geometry information at its core, whereas layer files store a link to a particular shapefile, any selection that has been made on that shapefile, and any symbology that has been used or specified to display the data. All right, I'll see you in the next lesson.